Good morning to all. Now we discuss combinations. Okay, so combination, that is a combination of n objects taken small or at a time, that is called an or combination of n objects is an unordered selection of n objects. Okay, it is an unordered selection of n objects. Okay, see, C of n comma r that equal to combination of, that is the number of combinations of n objects taken r at a time, that is the number of combinations taken r at a time, that is without repetitions, that equal to n factorial by r factorial into n minus r factorial, that is combinations are used for selection of things, that is called as a combination. Okay, a combination of n objects taken small or at a time, that is called an or combination of n objects is an unordered selection of n objects. See, C of n comma r equal to the number of combinations of n objects taken at a time, that is n factorial by r factorial into n minus r factorial. Okay. Next, see, P of n comma r equal to r factorial of C of n comma r, then C of n comma 0 equal to 1 and C of n comma 1 equal to n, then C of n comma 2 equal to n into n minus 1 by 1 into 2, and C of n comma 3 equal to n into n minus 1 n minus 2 by 1 into 2 into 3, and C of n comma n equal to 1. These are the rules. Okay, that is P of n comma r equal to r factorial C of n comma r, and C of n comma 0 equal to 1 and C of n comma 1 equal to n, then C of n comma 2 equal to n into n minus 1 by 1 into 2, and C of n comma 3 equal to n into n minus 1 n minus 2 by 1 into 2 into 3, and C of n comma n equal to 1. Okay, that is the conditions. Next one. Combination of with repetitions, that is V of n comma r equal to the number of combinations of n distinct objects taken small or at a time with unlimited repetitions, that equal to C of n minus 1 plus r comma r, that equal to C of n minus 1 plus r comma n minus 1 with unlimited repetitions. Okay, see, V of n comma r equal to the number of ways distributing small or similar balls into n number of boxes, and V of n comma r equal to the number of non-negative integral solutions to the equation x1 plus x2 plus and so on plus xn equal to r, and V of n comma r equal to the number of binary sequences with n minus 1 and r zeros. Okay, likewise we have to do the with repetition, that is C of n minus 1 plus r comma r. Next one, C. How many ways are there to distribute 10 different books among 15 people if no person is to receive more than one book? So ఇక్కడ చెప్తున్నాము 10 different books ఉన్నాయి, 15 like distribute 10 books ni 15 peoples ki distribute cheyali. So if no person is receive more than one book, so what is the process? P of 15 comma 10, that is the probability of 15 comma 10. Next one, how many binary sequences are there of length 15? So binary means 2, that is the length of sequence is 2 power 15. Okay, binary means 0 and 1. Next, how many binary sequences are there if of length 15 with exactly 6 ones and 9 zeros? 6 ones and 9 zeros, that is C of 15 comma 6, that is combination of C of 15 comma 6. Okay, next one, For example, a multiple choice test has 15 questions and 4 choices for each answer. First one, how many ways can the 15 questions be answered? So 15 questions answered cheyali kabatti it may be possible. That is the 4 ways. Maybe A or maybe B or maybe C or maybe D, that equal to 4 power 15 ways. See, how many ways can the 15 questions be answered? That is, since each question can be answered in 4 ways by the product rule, the 15 questions can be answered in 4 power 15 ways. Okay. And second, how many ways the 15 questions be answered so exactly 3 answers be correct? See, the 3 answers are correct, then we choose now C of 15 comma 3, and each of the remaining questions can be wrongly answered in 3 ways. Okay, 3 answers correct now. Remaining ante manaki 12 possibilities untayi kabatti the required number of ways equal to C of 15 comma 3 into 3 power 12. So doing the C of 15 comma 3 ways, that is each of the remaining questions can be wrongly answered in 3 ways. So 3 ways wrong ఉంటుంది కాబట్టి ఏం చెప్తున్నాము C of 15 comma 3 is the correct and remaining may be placed on wrongly answered, that is 3 power 12. Okay, next. How many ways the 15 questions be answered so that at least 3 answers be correct? At least 3 answers be correct. See, the 15 questions can be answered 4 power 15 ways. Number of ways in which at most 2 answers are correct. That is 3 power 15 plus C of 15 comma 1 into 3 power 14 plus C of 15 comma 2 into 3 power 13. Okay. The number of ways the 15 questions be answered so that at least 3 answers are correct, that equal to 4 power 15 minus 3 power 15 plus C of 15 comma 1 into 3 power 14 plus C of 15 comma into 3 power 13. Okay. Next. How many ways can 10 similar balls, that is 10 similar balls, be placed in 6 numbered boxes? So 10 similar balls unnai vaatini 6 number boxes lo arrange cheyali annam. So see, the number of ways distributing small or similar balls into n number of boxes, that equal to V of n comma r equal to, that is C of n minus 1 plus r comma r. So n equal to 6, r equal to 10. Okay, the number of ways distributing r similar balls, that is r equal to 10 into n number of boxes, that equal to 6 number of boxes, that are n equal to 6. Okay, so the number of ways equal to V of 6 comma 10, that equal to C of 15 comma 10, that equal to n means 6 minus 1 5 plus 10 15 comma 10, that equal to 3003 ways we can place the balls into 6 similar boxes, like 6 number of boxes. Okay, therefore the required number of ways equal to C of n minus 1 plus r comma r, n equal to 6 minus 1 5 plus 10 comma 10, that equal to C of 15 comma 10, that equal to 3003 possibilities are available to place the 10 similar balls into 6 boxes. Okay, next one. How many non-negative integral solutions are there to the equation x1 plus x2 plus x3 plus x4 plus x5, that equal to 50? See, the number of non-negative integral solutions to the equation V of n comma r equal to C of n minus 1 plus r comma r. So r equal to 50, n equal to 5, that is 1 2 3 4 5. So n equal to 5, r equal to 50. So therefore the required number of solutions equal to V of 5 comma 50 that equal to C of 54 comma 50 that equal to 3 comma like 3,16,251 ways. So ఇదన్నా వేయచ్చు, ఇదన్నా ప్లేస్ చేయొచ్చు, ఇదన్నా వేయచ్చు, ఇలా చేసిన ప్రాబ్లం లేదండి. ఓకే, సో ద నెంబర్ ఆఫ్ non-negative integral solutions to the equation x1 plus x2 plus x3 and so on xn equal to r that equal to v of n comma r equal to c of n minus 1 plus r comma r equal to 50, n equal to 5. So that is c of 5 minus 1 4 plus 50 54 comma 5 that equal to 54 comma 4 that equal to, this is the possibility ways to place the non-negative solutions. Okay, next one, ordered and unordered partition. See, in how many ways can 14 men be partitioned into 6 teams where the first team has 3 members, second team has 2 members, third team has 3 members, and 4th, 5th and 6th team has 2 members. See, totally 14 members ni 6 teams ga divide chestunnam. See, how many ways can 14 men be partitioned into 6 teams where the first team has 3 members, the second team has 2 members, the third team has 3 members, 4th, 5th and 6th team has 2 members. See, therefore the required number of ordered partitions equal to P of 14 is to 3 comma, see this one, 3 comma 2 comma 3 comma 2 2 2. Okay, that equal to 14 factorial by 3 factorial, 2 factorial, 3 factorial, 2 factorial, 2 factorial, 2 factorial. So likewise we have to solve the problem. Next one, see, in how many ways can 10 persons be seated in a row so that a certain pair of them are not next to each other? That is, a certain pair of them are not next to each other. Okay, now see, the number of ways 10 persons can be seated in a row that equal to 10 factorial, and the number of ways 10 persons can be seated in a row so that certain pair of them are not next to each other that equal to 2 members throughout the gap. That is 9 factorial into 2 factorial, that is required number of ways equal to 10 factorial minus 9 factorial into 2 factorial that equal to 10 into 9 factorial minus 2 into 9 factorial that equal to 8 into 9 factorial. Okay, next one. A box contains 2 white, 3 black and 4 red balls. 2 white, 3 black, 4, totally 9. In how many ways can 3 balls can be drawn so at least 1 black ball is included in the draw? So whenever we have to draw, at least 1 black ball included in the draw. Okay, see, the number of ways we can draw 3 balls from the box that equal to C of 9 comma 3, totally 9 balls. 3 balls will be drawn. Next, the number of we can draw 3 balls from the box so that no black ball is included. So if there is no black ball, that is C of 6 comma 3, therefore required number ways equal to C of 9 comma 3 minus C of 6 comma 3 that equal to 64 is the answer. Okay, the number of ways 3, that is the including black, that is C of 9 comma 3, without including, that is 6 comma 3. When including minus without including, the answer will be formed. See, the number of ways we can draw 3 balls from the box C of 9 comma 3. Next, the number of ways we can draw 3 balls from the box so that no black ball is not included that equal to C of 6 comma 3. Therefore, required number of edges equal to C of 9 comma 3 minus C of 6 comma 3, that equal to 64 is the answer. Okay. Next, from a group of 10 professors, how many ways a committee of 5 members can be formed so that at least one Professor A and one Professor B will be included? That is equal to 196 చెప్తున్నాము. See, 10 professors ఉన్నారు. So group of committee వచ్చేసి 5, that equal to C of 10 comma 5 minus, so that at least one of Professor A and one Professor B will be included, that equal to 2 professors are already included, that is C of 8 comma 5, that equal to C of 10 comma 5 minus C of 8 comma 5, that equal to 196. Okay, from a group of 10 professors, how many ways can a committee of 5 members can be formed? So how we can form? That is actually C of 10 comma 5, but here A and B will be included, so included will be removed from the totally. The given answer is a 196. That is C of 10 comma 5 minus C of 8 comma 5, that equal to 196 is the answer. Okay. Next one. Next, binomial coefficient. An algebraic expression containing 2 terms is called a binomial expression. That is, an algebraic expression containing 2 terms is called a binomial expression. That is, bi means 2 terms. See, thus the general type of binomial is a plus b comma x minus 2 comma 3 plus 4 and so on. Okay, simply what we say, an algebraic expression containing 2 terms is called a binomial expression. Okay. Next, the expression of binomial raised to a small positive power can be solved by ordinary multiplication, but for large power the actual multiplication is laborious, and for factorial power actual multiplication not possible. By means of binomial theorem, this work reduced it to shorter form. This theorem was first established by Sir Isaac Newton. Okay, this is the binomial coefficient. So what is meant by binomial expression? An algebraic expression containing the 2 terms. It is called a binomial expression. Next, next one. Let x and y be any real numbers. N is a positive integer. Then the formula of binomial theorem is x plus y whole power n equal to sigma r equal to 0 to n, n r, y power r, x power n minus r. That is, let x and y be any real numbers. N is positive integer. Then the formula of binomial theorem is x plus y whole power n equal to sigma r equal to 0 to n, n r, y power r, x power n minus r is the formula of binomial theorem. Okay, that is sigma r equal to 0 to n, n r, y power r, x power n minus r. Okay, next one. Next, binomial coefficients. Notations. What are the notations? See, C of n comma 0 equal to C0 equal to 1. Next, C of n comma 1 equal to C1 equal to n. Next, C of n comma 2 equal to C2 equal to n into n minus 1 by 1 into 2. Okay, n into n minus 1 by 1 into 2. Then C of n comma r, that equal to CR equal to n into n minus 1 into n minus 2 into and so on n minus r plus 1 by 1 into 2 into 3 into and so on r. It is CR equal to n into n minus 1 into n minus 2 into and so on n minus r plus 1 by 1 into 2 into 3 into and so on r. Next, C of n comma n equal to, that is Cn equal to 1. Then C of n comma r, that is the number of combinations of n objects taken r at a time with repetitions is n factorial by n minus r factorial r factorial. That is n factorial by n minus r factorial r factorial. Okay. Next one. Some more entries. C0 minus C1 plus C2 minus C3 plus and so on minus 1 whole power n into Cn equal to 0. Next, C0 plus C2 plus C4 plus and so on, that equal to C1 plus C3 plus C5 plus and so on equal to 2 power n minus 1. Okay. Next, C1 plus 2C2 plus C3 plus and so on plus NCN equal to n into 2 power n minus 1. Next, C1 minus 2C2 plus 3C3 minus and so on plus minus 1 power n minus 1 into n into Cn equal to 0. Okay, n into Cn equal to 0. Next, prove that sigma r equal to 0 to n C of n comma r into 2 power r equal to 3 power n. So we know that x plus 1 whole power n equal to sigma r equal to 0 to n C of n comma r into x power n. Then putting x equal to 2, that is 3 power n sigma r equal to 0 to n C of n comma r 2 power r. Next, let small n be a positive integer, then for all x and y, that is x plus y whole power n equal to C of n comma 0 into x power n, C of n comma 1 into x power n minus 1 y, C of n comma 2 x power n minus 2 y2 plus and so on plus C of n comma x power n minus r into y power r plus and so on plus C of n comma n into y power n, that equal to sigma r equal to 0 to n C of n comma r x power n minus r y power r, then x plus 1 whole power n equal to sigma r equal to 0 to n C of n comma r x power r, then 1 plus x, that is 1 minus x whole power n equal to sigma r equal to 0 to n C of n comma r minus 1 into x power r. Okay, that is 1 plus x whole power n equal to sigma r equal to 0 to n C of n comma r into x power r, 1 minus x whole power n equal to sigma r equal to 0 to n C of n comma r minus 1 whole power r into x power r. Okay, and x plus y whole power n equal to C of n comma 0 x power n plus C of n comma 1 x power n minus 1 y power 1 plus n comma 2 x power n minus 2 y2 and so on n comma r x power n minus r y power r plus and so on plus C of n comma n into y power n. This sigma r equal to 0 to n C of n comma r x power n minus r y power r. Okay. Next, tomorrow we can see the multinomial. Okay.